Motion sensing technology, best known in computer games, is vastly improving Queensland scientists' ability to quantify habitat complexity in mangroves.
The reason why we're interested in finding a way of measuring complexity of habitats is because measuring structural complexity is a key question in ecological studies.
At Griffith University's Australian Rivers Institute, scientists are using the Kinect line of devices developed by Microsoft to deliver precise, real-time, three-dimensional data in greater efficiency and at a fraction of the cost of current imaging techniques.
That's why we actually wanted to find a cheap way, an efficient way of characterizing the structural complexity of mangrove environments.
Until now, the alternative has been to use expensive and mainly stationary laser scanners that cost upward of $100,000 and require considerable computing power for data processing.
We were interested in looking at how mangrove ecosystems function, and most of the ecosystem services, like providing nursery sites to juvenile fish and crustaceans, or dampening the action of waves from storms and also tsunamis, and also how mangroves can actually store carbon in the habitat.
What we see on the screen is how the Kinect operates or actually creates a three-dimensional object in parallel processing in real time. It detects its own position, and from that it can stitch together literally a point cloud that it then can convert into what we call a mesh object.
By using the Kinect sensor, a gaming laptop, and working at low tide, the researchers can create realistic 3D digital models of complex mangrove environments.
One possible way of taking this finding forward is to 3D print these models and actually take the actual forests to give us the environment, the perfect environment for actually making further ecological observations and experimentation. This has not been possible before without this technology.